So for the next example, like we just did in the previous example, using our sum and difference formulas, you may have to draw a reference triangle. So here, again, I'm just going to change this to tangent alpha. So tangent alpha is 1/2, and again, sine of beta is equal to -4/5. So again, to figure out where angle alpha is going to fall, you need to look at the conditions that they're giving you. Notice they're telling us that angle alpha is between pi and 3 pi over 2. So I know then that this reference triangle for alpha is going to have to be drawn down here in quadrant 2, because it has to be located between pi and 3 pi over 2. Remember, by your SOHCAHTOA, tangent is the opposite over adjacent. So my opposite side is 1, my adjacent side is 2. Again, make sure I put my negative signs there because I'm on the negative side of both the x and the y axis. So to find the hypotenuse, you have to use your Pythagorean theorem. -1 squared plus -2 squared is equal to c squared. So 5 is equal to c squared, so the hypotenuse is going to be square root of 5. So now let's take a look at my second angle and what they're giving me. Again, they're telling me that angle beta is between -pi over 2 and 0. So remember, when you're dealing with a negative angle measurement, there's -pi over 2, there's 0. So what I'm going to have to do is sketch this reference triangle down here in quadrant 4. Again, they're telling you that the sine is -4/5. Again, by your SOHCAHTOA, that's the opposite over the hypotenuse. And again, this is a Pythagorean triple, or you can use your Pythagorean theorem, so this third side is going to be a 3. So remember, location is key. You've got to make sure you set up your triangles in the correct quadrants. So now I'm ready to go ahead and find my sine difference. Again, here's my sine difference formula. Sine alpha cosine beta minus cosine alpha sine beta. So now I want to go to my alpha triangle and I want to set up my SOHCAHTOA. Sine, remember, is the opposite over hypotenuse, so that's going to be -1 over square root 5. Cosine beta. Go to your beta triangle. Remember, that's the adjacent over the hypotenuse. Now I need to set up my cosine ratio, going to my alpha triangle. That's the adjacent over the hypotenuse. So again, I went to my cosine, again the adjacent over hypotenuse. Now I need to go to my beta triangle. Sine is the opposite over hypotenuse, which is -4 over 5. Remember to multiply before you add and subtract. So remember, when you are multiplying fractions, you multiply the numerator and you multiply the denominator. So again, this is going to give me -3 over 5 square root 5. Now be careful, a negative times a negative is a positive, but you still have the subtraction sign separating it. That's going to be 8 over 5 square root 5. So now what I can do is I already have a common denominator, so I'm going to go ahead and just add this together. So that's a -11 over 5 square root 5. But what I need to do is rationalize the denominator, so I have to multiply the numerator and denominator by square root 5. So I have a -11 square root 5 over. Now remember, this is 5 times square root of 25, which is 5, so that's going to give me a 25. So there's your sine difference. So now we're going to go ahead and do the cosine sum formula. So again, your cosine sum formula is your cosine alpha, cosine beta, minus sine alpha, sine beta. So I already have my triangle set up, so I want to go to my alpha triangle. Remember, cosine is the adjacent over hypotenuse, so that's -2 over square root 5 times. Go to your beta triangle, set up your cosine. Cosine is the adjacent over hypotenuse. Sine alpha, remember, go to your alpha triangle again and set up the sine ratio. Sine is the opposite over hypotenuse. That's going to be -1 over square root 5. Sine beta, go to your beta triangle and set up your sine ratio, which would be -4 over 5. Again, be careful of your signs. Multiply straight across. That's going to be -6 over 5 square root 5. Minus, a negative times a negative is a positive, so that's going to be 4 over 5 square root 5. Again, I already have a common denominator, so I'm just going to go ahead and add these two fractions together. Now I can simplify this fraction because 5 goes into -10 -2 times. So that's actually simplifies to -2 over square root 5. Now I need to rationalize the denominator, so multiply the numerator and denominator by square root 5. So my final answer would be -2 square root 5 over 5. So now it's my tangent of alpha plus beta. So my tangent sum formula is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So I go to my alpha triangle and I need to set up the tangent. Remember, tangent is the opposite over adjacent. So that's going to be -1 divided by -2 or 1/2. Go to your beta triangle. Opposite over adjacent is going to be -4/3. Over 1 minus, again, I've already got the tangent alpha, that's my 1/2. I've got my tangent beta, which is -4/3. So now when I multiply these two fractions in the denominator together, I end up with 1/2 times -4/3. That's going to give me -4 over 6, but that's going to become a plus. So that's going to be +4 over 6. Now, depending upon how you want to simplify this, we're now entering the magical world of algebra. You can use your complex fraction, multiply everything by the LCD. The LCD for all of these fractions is a 6, so I'm going to multiply every single term by a 6 because I want to get rid of the fractions in the numerator and fractions in the denominator. So 1/2 times 6 is 3. 4/3 times 6 is going to be an 8 because, again, 3 goes into 6 2 times and -4 times 2 is 8 over 6 plus 4. So that's going to give me -5 over 10, which is -1/2. Again, you could have subtracted, got a common denominator, subtracted this fraction, common denominator, added in the denominator, and then multiply by the reciprocal as well. But this LCD trick would save you a lot of time. So there are going to be times where you have the clashing of both worlds, where you have the unit circle and you have a reference triangle problem in the same exact problem. So for example, and it's pretty obvious when this happens because you're going to see inside the parentheses an angle along with your variable theta or alpha. So again, here's my sine difference formula, because again, I'm subtracting these two angles. One angle I know, the other one I do not. So I'm going to use my sine difference formula. So sine alpha, cosine beta, minus cosine alpha, sine beta. So again, draw your reference triangle, and they're telling you that theta is in quadrant 4. So again, when I draw my reference triangle, I'm going to set it up in quadrant 4. Remember, cosine is the adjacent over the hypotenuse. So my adjacent side is 1, my hypotenuse is 4. So I'm going to have to use my Pythagorean theorem to find the third side of the triangle. So 4 squared is equal to 1 squared plus b squared. So 16 is equal to 1 plus b squared. So 15 equals b squared, so this side is going to be negative square root 15. Remember, you're on the negative side of the y-axis, so you want to make sure you have a negative sign here. So now what I'm going to do is I'm going to replace in my sine difference formula, anywhere I see an alpha, I'm going to put a theta. Anywhere I see a beta, I'm going to put a pi over 6. So sine of theta, cosine of pi over 6, minus cosine of theta, sine of pi over 6. So to find the sine of theta, I need to look at my reference triangle. So sine, remember, is the opposite over hypotenuse. This is going to be negative square root 15 over 4 times. So now cosine of pi over 6, that's going back to the unit circle. So pi over 6 is in quadrant 1. Cosine is my x-coordinate. So at pi over 6, the x-coordinate is square root 3 over 2 minus cosine theta. That is, remember, my adjacent over hypotenuse, which is 1/4, times the sine of pi over 6. Remember, pi over 6 is in quadrant 1. Sine is your y-coordinate, so that's going to be 1/2. So I end up with square root of 45. When I multiply these two fractions together, negative square root 45 over 8 minus 1/8. I can simplify this radical because I have 9 times 5, or 3 times 3 times 5. So this simplifies to negative 3 square root 5 minus 1 all over 8. So this is mixing and matching when you have both the reference triangle and you have the unit circle angle. So now cosine sum formula, here's my alpha plus beta. So I'm going to look at my cosine sum formula. Cosine alpha, cosine beta, minus sine alpha, sine beta. Again, anywhere I see a theta, I'm going to replace it with, anywhere I see an alpha, I'm going to put my theta. Anywhere I see a beta, I'm going to put pi over 3. So cosine theta, cosine pi over 3, minus sine theta, sine pi over 3. So again, go to my reference triangle, cosine of theta, that's the adjacent over hypotenuse. Cosine pi over 3, that's from my unit circle, that's going to be 1/2. Sine of theta, go to my reference triangle, that's going to be my opposite over hypotenuse, that's going to be negative square root 15 over 4. Sine of pi over 3, the y-coordinate at pi over 3 is going to be square root 3 over 2. So when I multiply, that's going to give me 1/8 minus a negative turns into a positive, square root 45 over 8. I already simplified the square root of 45. That simplifies to 3 square root 5. So this final answer will be 1 plus 3 square root 5 all over 8.